All right, so next up, we have a panel discussion for AVL systems. I got Steve's slides ready to go here, so we'll start with those. So what we'll do is each of us will talk a little bit about our respective systems, where we're at, what we're doing, and then we'll open up for questions from the group. Or just
AVL, we're kind of doing two different things. We have what our program is on snowplow trucks, which a lot of you may know a little bit about that because we talked about it. And then light duty stuff, we're doing a little bit of telematics. As I think, or maybe it was Lisa when we were talking about the telematics and light duty stuff. We went with Verizon Network Fleet simply because it was on the NASPO contract. We already had a contract with Verizon through the NASPO contract for all of our cell phones within ITD, and so it was just an easy way to get involved with it. When we started into telematics on light duty stuff, we basically asked our districts. We did not mandate it from a headquarters fleet, simply because within my office I don't have a very large operating budget, so we knew whatever the operating expenditure associated with telematics and light duty stuff had to come from the districts. And we visioned that tool being something to help the districts manage their equipment as opposed to headquarters overarching management of it. ITD is very autonomous in that we expect the districts to do a lot of the fleet management as far as operations, making sure stuff is done, and it's not controlled by Jeff Kelly or I in Boise. So as a result, we said we wanted to do this, who wanted to get involved, and we basically put a few devices on some headquarters vehicles, and we had 2 districts that jumped in and said they wanted to try 10. One district within a couple months bought 50 more, to where they have, I think, almost 70 units now within their fleet. Another district jumped in with 10. So so that means we had 3 districts out of the 6 doing something, plus headquarters, and the other 3 not wanting to do anything. So over the evolution of about 2 years now, all 6 districts have now bought some devices. It's still very limited. We have, I think, 15 devices up in the District 1 Coeur d'Alene area, 5 in the Lewiston area. District 3 in Boise just bought 5. The reason they're behind the schedule is their district engineer said this is just Big Brother and I don't want to do that from a culture standpoint. But now they've started to see the value of some of the things that the other districts are talking about. District 4 down in the Shoshone, Twin Falls area, lower part of Idaho is 10. Heaviest user is in eastern Idaho. Those 2 districts combined have probably about 120 units over there. So we're evolving. We're still trying to learn and understand what we can do with all that data, but we're getting more familiar with it. We're not to the point that we're ready to do anything like Colorado or Caltrans, is to say we know exactly what we want to do with that yet. So we're evolving from that aspect. What the presentation is a little bit is on our snowplow stuff. We got heavily involved in snowplow AVL in 2012. I don't think we were quite the first, but we were probably the one that got in really heavy. At the time, we were looking for a new spreader controller. We had basically just bought our first Cirrus units. We had a project in play to do mobile data collection and AVL on snowplows. It was awarded, I don't even remember the name of the contractor, but we spent a year with them and that project failed miserably. What happened is one of our requirements is you had to basically talk to every spreader controller we had, and then we wanted consistent data. So their system involved using another third-party box in the truck, talking to the controllers, downloading cellular modems and cellular communication, a website to go get the data and things like that. What we found in the translation from each spreader controller to their box and out, the data became junk. We could literally look at data out of the controller, compare it to what the AVL system did, and it was off by an erroneous amount. And so for that reason, we ended up canceling it because we knew at that point in time the data we were going to collect and use wasn't valuable. When we got into Cirrus, a couple things came to play. They already had a data recorder in their unit, so we didn't have to buy a third-party box to actually record the data. As I said, the other solution was cellular-based. Idaho being very rural like most of us, there's probably a third of Idaho there is no cell service, so that meant all the trucks in those areas cannot communicate. We wanted a statewide solution. And they already had basically Wi-Fi communication. And ITD had gone to the point we had Wi-Fi at every single maintenance shed anyway. So communicating via Wi-Fi was a statewide solution to us, and their system already had that. So it became just a natural fit to go with Cirrus. Now I only had one vendor. I didn't have another third-party vendor. I didn't have any more hardware in the truck other than a Wi-Fi bridge, and I could communicate and keep all of my own data on our own network, on our own servers. So we don't pay anybody to host the data or report on the data. So that was the direction as to why we went this. We currently have 409 single and tandem axle plow trucks and 2 tow plows that we're recording data from, and that we've been recording that data since 2014 at that level. So we have about 5 years of data. Kind of what I thought this presentation was is to tell you how we're using that data. So that's really what the bulk of this is. We use it in conjunction with our RWIS network. I'll go over that. We use it to communicate directly with our maintenance management system for reporting of data. And we're looking at it, the most importantly, is snowplow operator assessment, what our trucks are doing, what our people are doing, and are they doing the things that we want them to do. So let's talk about integration with AVL. We have an extensive RWIS network, I think one of the largest ones around the country, 128 sites. This is an old slide, I think we're up to about 134 now. They're all BISOLA, so you get all the infrared sensors, non-invasive pavement sensors across the state, and different things. This is kind of the locations. And if you've ever seen a BISOLA graph, when you start looking at all that data, this is what it looks like in all these squiggly lines. Each one of these lines is a different thing. But the key about this, if you haven't seen it, is what we did working with Cirrus and with BISOLA is they created the screen. Is down here you see these little trucks. That is basically a truck. Every time that truck went by that RWIS site, we now post, and the guys can look at this RWIS graph and then look at and see then the trucks went by that. They have the ability now to drill down on each truck and find out exactly what the truck did as it went by from the mobile data collection aspect of it. So what we were trying to do, let me back up one, is if you look at the graph, I think this pink line is the snow level. So you can see, or grip, prominent one. That's one of the things we track is basically the grip on a roadway. Grip is defined by how much snow, water level, and is accumulated on the roadway. So as we got to looking at this, you could see every time the truck went by what would happen to the grip and different things on that. So what we wanted our guys to understand is when you would look at this graph, see what happened to the pavement, what's your application rate, and what it did. So this is from one up on US 12. You can see that within this 24 period how many times we went by that RWIS site. The overall condition of the roadway, this being the pink line, ideal being here, we're clear down here, so our roadway was not in very good condition. So we wanted this to be a learning tool for our operators to get better. Here's just another drill down, better say what it looks like, what they were doing. So after they reviewed that last storm, this is a very similar storm about 3 weeks later. You can now see the number, or the graph, is much better. It's at a higher level. You can see is when we started to lose grip, the truck went by, and we started gaining it back. And you'll also notice in the same time frame, same storm parameters, how much less we were actually on the roadway. So in this particular case, we're trying to use our AVL as a learning tool is to understand what the truck is doing, what the results are, and then get better and improve their performance over time. So this is how we're integrating AVL with our road weather information to understand what we're doing. Very high level, but anyway. So now let's talk about one of the other things we're using the data for is we're importing that data directly into our maintenance management system. We started to recognize that we're asking our people a lot to be out on the road for 12 hours and then to remember what routes they were on, what products they put on each route, and where they turned around and all that stuff. Well, all that information that you need for basically a sanding, what we could call a sanding log report that operations would use, was contained in the mobile data collection. So if we're collecting that data electronically in the truck, and then we're asking an operator to review that data, then manually enter it into another system, why not integrate the two systems together and do it automatically? And so that's what we've accomplished. You can see some of the different things. Like I said, we have agile assets, what it takes to input information. So we created this winter automated reporting system. So it takes all that information and puts the information in the format where the operator just brings up the system and it shows all the data right up front. When he has one thing he has to do. One, verify that the materials is accurate. Because we all know, even though an auger sensor says you're putting out material, you could have ran out of material 20 minutes ago and put out more material. So they need to validate and things like that. and they need to tell the system which stockpile they got it from. That's the input. They hit submit, it automatically creates all the work orders in our maintenance management system, all the day cards, does their timesheet for them, and all that. The basis and the theory behind this is literally a guy could come in, view his data within 10 minutes. He could look at it, correct it, and submit it and be done with all of his data entry for the day, even after being on the road for 12 hours. There has been some glitches in the system. It's very time sensitive in trying to basically convert all of those GPS coordinates to our road network, because the whole point of this is trying to understand what we're doing to our individual road network. So we're in the process of updating that. It won't be for this winter, but it will be forthcoming. So that's the second use that we're using for the data. And then the third one is, again, just trying to get better. So we're looking at storm summary reports, trying to understand, you know, if we know the storm, very similar to the AVL aspect, what our people did, you know, trying to understand the level of effort, how much materials we're using, and things like that. So we have an exception report. We don't want people spreading granular material at 60 miles an hour because it doesn't stay on the road, it bounces down the road. So we have an exception report if they're spreading over 35. The foreman is notified. Again, all trying to improve better use of materials. So we're looking at application rates, spring lanes. We don't want to do a lot of blasting. We want our guys to understand that their clear roads metric and the application rates, if you're doing that, those has been, let's say, researched or engineered out as to have it right. Why are you hitting blast? Why are you throwing extra material when you don't do it? All in an effort to start trying to save material. Last year was the most expensive winter for ITD. Again, it may be fair in comparison, but we went through $8.9 million worth of salt. We can't afford that this year. And we can't afford it any other year. So now we're in a big strategy is to still try to meet our performance metrics, but reduce our materials. And this is how we're using material from AVL to do that. So one of the new tools is this Mobility Cost Efficiency Index. It compares clear roads, application matrices to what the AVL data says, what the operator actually did, and their actual results. And we give our operators a score so they can understand if they need to be improving or where they need to go with it. Real quick, that's how we're using AVL data. Greg.
So your overrun and snow and ice, that would be last biennium, right? Correct?
No, we're on an annual appropriation.
Okay, I'm sorry.
Yeah, we're not like Washington Bayern. So each district gets the operating budget to buy their winter materials. If they go over, what that means is come spring, all of our guys are picking up litter, maybe mowing, but they're not putting any new asphalt on the road and improving the roads because we basically used up all the money buying snow and buying winter chemicals moving forward. So it's a balancing act. ITD is a dedicated funding agency under Idaho law. We can only spend the revenue that we incur through registrations and gas taxes. So if we have a bad winter and we have to replenish all of our salt, we don't buy asphalt. We cannot go back to the legislature and ask for additional money because there's none there.
So what's your time period? January, your calendar year, fiscal year?
July to June is the fiscal
okay.
year.
Thank you.
I got on this panel. I was kind of a little surprised because I said, you know, from my perspective, when I think about AVL, I think about snow and ice. I think about how do we get data for snow and ice. Because in my job, I've been focused on that part of it. But I'm going to go back a little bit and touch a little bit about what Lisa talked about the other day and give you an idea of where Caltrans is today. Several years ago, I'm going to ask a question real quick first. So who has enough money to replace their fleet? Who has an adequate fleet replacement budget today? Nobody, huh? Nobody. Caltrans doesn't either. And you know, you're kind of stuck with, when you know, the easy answer is, well, go ask for more money, right? Go ask for more money from the legislature and they'll give you more money. Well, when you go ask for more money, they're going to ask you a lot of questions back. And they're going to ask you questions like, well, how do you know your fleet isn't too big? And that was certainly a thought, because about 10 years ago, the governor put forth an executive order, and he said, you know, we're going to go through and audit all of state of California fleets, not just Caltrans, but all state of California fleets, because there was a thought that state fleet was too big. And we went through that process, and as Lisa talked about the other day, at the end of the day, we took about a 10% fleet reduction, and we also took a 25% hit in our fleet replacement budget. So we were sliding back the other way. And then you get into questions about, well, how do I know that my fleet is really the right size? And I think that audit really brought a lot of things in question for us. And I think the next thing that happens is, how do I do a better job with that, and do I have the right types of equipment? So it starts to bring in a lot of questions about, how do I get this data? So if I fast forward a little bit, we still have this fleet replacement budget problem, but we started trying to get better data to know that we had the right size fleet and it was the right type of fleet. And so we start down this road, and we ended up with getting a GPS system to get good data on fleet use. How much did we use the fleet, and where it was. So Lisa talked a lot about that the other day, and from that information, it spawned this whole utilization group within Caltrans. And if I think about where we were, 4 or 5 years ago to where we are now, we're able to say that we know how much our fleet is being used. And, Lisa showed a data the other day, is like 96%. So we have good utilization now, and we know that we're trying to get to the right types of equipment. So that spawned something else off, is that we said, well, how do I get more use out of specialized equipment? Well, we started doing these multi-bodies on equipment, specialized equipment especially. So plow trucks, we use them in the winter. What are you doing with them in the summer? So we're doing body changes where it's a quicker body change, where we can run that same plow truck as maybe a tanker truck or a cargo truck in the summer. We're working on things like that. Some of what we do in our control systems now, because we've gone to that multi-use type body, we're looking at, well, how do I control the body? How do I know that my vehicle control the body and that it knows what it's trying to control? So we've moved forward with a more advanced control system. Well, that is also part of our snow and ice control system. That happens to be a Muncie Advantage system that we're using now. But we're at the point where we're telling the control system that I have this type of body on it, and it knows what to do with it. So that all spawns, is how do we standardize our fleet more, how do we get utilization better out of it? And that's really what has pushed, I think, when I talk about AVL, it's really bigger than just snow and ice, right? And I'm hoping that we're going to get to the point where we can go to the legislature and with this data that we're getting through AVL, and be at a point where we can get more funding to get a better fleet replacement budget. So that said, that's kind of, what we've been doing in the background. We had a meeting, it was a peer exchange group, about 4 years ago, Lisa, I think, and we got a lot of information from AVL. It was a real eye-opener. We also invited our maintenance partners to the meeting at the same time, and I think it was an eye-opener for them too. We were trying to get them more engaged about all this information that could be available. From there, we started working on, we knew at some point that maintenance was going to say, I want to get all this data. I want all that cool stuff, like how do I get a camera in the truck, and how do I get all the data like Steve's talking about. Steve mentioned the other day about using a laser to tell you friction on the road, and to me that's kind of like the holy grail, I think, in snow and ice control or winter control. So we're trying to get there, but we know maintenance at some point is going to want to be there in an instant. So we've gotten on this mode of, how do I make AVL-ready trucks now that are going to be ready when maintenance says, I need all this data now that we can turn it on. So that's where we're at right now. Long story, let me fast forward through some of these slides. This is our old spreader control systems. These were all the Muncie MSP 402s. These have been in our fleet for several years. We've had the ability to actually pull data. It was mostly granular data from the vehicle. You could put it on a card or chip or whatever you want to call it, and put it into a computer. We actually have the ability to retrofit these and push data through Telematics if we so choose, and it'll put us back about probably 10 years and in what we can get information out of our vehicles. So vehicles that are about 10 years old and forward, we'll still be able to push data with Telematics at a very just granular data. So it's not a lot of data, but we can certainly get that. It's the control system. If you see over there on the left, it's the old stack valve system, air over hydraulics. That's how we ran our plow controls. This is the new system. Over here on the, let me see if this works. These are all button features where we can push a button and tell the system what body is on the truck. Muncie, the system can take up to about 255 types of bodies, so we've got a lot of capacity there. And it also over here you have your, your regular. This system will not only do granular, it'll do brine, and it'll do pre-wet to measurement. That's like I said, it'll do anti-ice, pre-wet, granular. That's the new system. That's the Muncie Advantage that we're putting in. Some of the other things that happened when, it starts to be a snowball effect with all these things that I think about it. We used to have 4 controls in the cab to run your plow truck. Your front nose plow had a single control joystick, and then we had 3 levers to control your wing. With these systems, we've changed to an electric over hydraulic valve actuation instead of air over hydraulic. Now we're down to just 2 joysticks basically to run, one for the nose plow, one for the wing. That's the new valve block. It's quite a bit different. People talk about, yeah, that's the Muncie. It's in its own compartment now, so it's not out in the open. It's probably going to be a little bit of a stretch when we put them out in the fleet, and our mechanics have to work on them, but that's the way technology is going. So these are all the different body types that we can put on right now. All the way, last couple of years ago, we started buying the more efficient sander units with the E-Pokes and the Henderson FRSs. We've gotten into some testing to actually measure the spread rate and to measure how efficient it is. We're still in process on that, but we have found out that we do have material savings using these types of spreaders like the E-Pokes or the Henderson FRSs. In fact, in some of our testing, what we found out was when regular tailgate sanders, unfortunately, the majority of our material was actually throwing off far to the right, and probably most of it wasn't even hitting the road. Those are some of the old systems. We're trending away from those. We've on all of our new plow trucks where it gets a sander body, we put on more efficient bodies. That's where I foresee the future to be. We're trying to save material and be more efficient with that. Also, we have these other body types where, like I said, in the summertime, we can run tanker bodies. We can run them as brine bodies. We're actually we're going to do an asphalt patcher body as far as our roll-off trucks. And again, when you put that body on the truck, you'll be able to tell the truck, this is what's on the truck, and it knows how to control it at that point. This is the data stream that we have available now. We have a contract where we're doing a proof of concept contract with Geotab. Maybe Bob can cover that a little bit more. We're doing, like I said, the proof of concept. We're pushing data to them, seeing if we can get the reports back, what they look like. So this is a shot of what Geotab has now. If you look over here, this is all the specific ones you can tie to, and it ties down into the details of the truck. Obviously, we're trying to get to the point where Idaho is. I'm always impressed when I watch what other states are doing, because I know that's where we want to go. That's kind of where Caltrans is right now. We're building AVL-ready trucks. We've got a relationship now with Geotab with the proof of concept. And as soon as we get that data, I think we're going to, follow in steps behind the guys that are leading the way for us. Do you have any comments?
So I think the key for AVL for us is that we really don't know what the capabilities are from Geotab. And so this proof of concept, we've identified some target items that they have to meet in the contract, but we're also interested in seeing what they do after that. Some preliminary visions that I see is that we're just kind of scratching the tip of the iceberg here, what the capabilities of it are, because Geotab is a very experienced analytics company. They do a lot of push button reports for you, but you also have access to all the other states' reports too. So it's not just, you do a one-off canned report for you and Network Fleet, and it's yours, and that one person that made it for you has control over it. It's more on a global scale. I think that's really going to help, because that report, development side of things is really expensive at times if you're going to develop a bunch of ad hoc reports for us to share those. I think the coolest thing about AVL is really what we're looking at. We have an app right now called Quick Maps that's forward facing to the public, and last year they populated the truck icons on it, And if any of you ever driven over the 80-50 corridor, that's where the ski resorts and the casinos and everything are. It's very political. They want that road open 24/7. The key is, though, is with the cameras, the public will be able to click on that truck and see what the truck is driving in. And the hope is that they're gonna say, we're not going right now, we're gonna wait. And hopefully that's gonna influence traffic behavior. It's gonna give us, because what happens is the road gets so plugged up with cars that the plows can't get around up there. The trucks are all crisscrossed in the road. And so we spend a lot of time just pulling people over the top of the mountain and not plowing the road. So the hope is, with the reduction of traffic on the road and the improved public traffic behavior, we're gonna be able to keep the road open more consistently. We're also going to do the same thing with the driver scorecards. We still haven't got to the point where we're sitting and meeting with the union, so you guys are way ahead of us on that. I don't see that it's gonna be really an issue, because it's not the camera looking at the driver, it's really looking out the window. We've actually got some requests already from people that are driving trucks for us now, requesting a camera because of the errant driver behavior to them, and they just want to make sure that they don't get blamed for an accident that they didn't cause. I think the culture is changing. Instead of them looking at it, hey, it's Big Brother looking at me, it's, hey, this is protection for me, because if you're out there doing the right thing, then you don't have anything to worry about, right? As far as, we're looking at efficiencies too, and in the past, we don't really have any way to measure what was efficient compared to what we are doing now. So these bodies that we're buying, claim that they put out 30% less material with the same results. And that's some of the material savings that we're looking at in the future. We're building 100 of these plow trucks a year. So they're slowly getting into our fleet. We've got, close to about 900 snow plow trucks. Once that fleet gets turned over, I think we're gonna have a much better look at what we can do to be more efficient, to make sure that the drivers are doing the right thing, and then strategically look at what do we need to do, because really this can go into the design of the freeway. Maybe we need more snow storage in some areas, so when you do a rehab on a section, you build the snow storage area for it instead of the box canyon type thing, right? Maybe you make a slope so you can throw it up on top of the slope. It really has a lot of potential in the future, and we're pretty excited about it. We learned a lot of lessons, because when you go with your entire fleet, we have 12,000 units in our fleet. When you go with that many GPS units, there's a lot of lessons learned. So when we went into this, and just so you know, this is not a Caltrans contract. This is a DGS statewide contract, so anybody can use it, any department, any municipality also. So, and if you do decide to put GPS on your fleet, it's mandatory that you use this contract. And it was a partnership between us and DGS. We were pretty much the model, because we've already had it, and they didn't. And so we were really involved in developing the scope, and we're basically taking over the POC for them and working with the vendor to get it done. So I'm really excited about what's to come. And I hope that maybe at the next one, at the annual next year, we'll be able to share some of the success stories of this new contract being implemented. So within about 90 days, we should be finished with the POC.
Like Steve was describing his system, that we had kind of the same end state goal in mind, but we went about it maybe a little different, a different approach to how we got to that. So CDOT started seriously looking at AVL and plow trucks about 2014. They did a pilot test with about 100 units, and at that time it was decided that the vendor that was going to be our telematics provider would be Zonar, and that was primarily because in addition to all the the standard telematics functions, they also had the electronic pre and post trip inspection, ELD capability, and a few other features that were kind of rolled up into their system that CDOT was interested in looking at. So after that pilot program, about mid to late 2015, we started going to a full implementation of that system in all of our vehicles that require a commercial driver's license to operate. So that pre and post trip function was there electronically. And then we started working with them to develop things that were more specific to snow and ice operations. I hope everybody should have gotten a chance to climb up in the cab of one of our trucks yesterday and kind of see how our trucks are laid out. Currently, our trucks that have been built since I've been here, so probably for about the last 6-7 years, have the Cirrus spreader controller in them. They all have the Henderson snowplow package on them, so we have some consistency there. So I think it was Steve mentioned, going back about, or was it Chris mentioned, going back about 10 years, we kind of have a standard snowplow truck that we can work with. And Cirrus is already set up to capture that data, and we can transmit that spreader controller and plow data through the Zonar tablet, or the Zonar system, back to our traffic operations center, where they can put information like the location, direction, and speed of the plow on a public-facing website, which is called cotrip.org. And the traveling public can take a look out there and see where our plows are at, what direction they're doing, and which plows are out there servicing which roads at what time. If anybody's thinking of doing that, here's a lesson learned for you. If you're going to put your plows out there on a public-facing website, have a timeout on that reporting. So, if your guy comes off shift, parks the truck in the yard, or if he's in there loading up with sand or liquid, and he's down off the roadway for an hour or so, the public's looking at that website going, well, why is this truck sitting in the yard for an hour? Why isn't he out there plowing? They don't care about, the guy's got to have a lunch break, the guy's got to reload his truck. They don't care about all that. So we put a 15-minute timeout on there. If the truck's been inactive or stationary for 15 or more minutes, it drops off the radar, so to speak, and then it'll come back once it goes back into service. That saves our traffic operations center and our superintendents a lot of phone calls from armchair quarterbacks out there in the public. Briefly describe what a connected snowplow is. I already described some of the things that it passes on. It's also linked into the maintenance decision support system, which in our case is facilitated by Iteris. Most of you probably know who they are. So we have a communication between our driver out on the roads and Iteris. So the Iteris is providing weather data through the Zonar tablet to the operator of the truck, so he can see the weather radar, get a look at what storm is about to come his way, what the current weather conditions are in real time, and then as he's servicing his route, he can also make inputs into the system that feeds back to Iteris, because Iteris archives that information so that they can analyze it, and they can say 2 years from now, that storm that happened 2 years in the past was very similar to this one that's happening today. Here's what treatments were applied. Here's what the recommendations were that actually worked and were effective on that roadway. So again, that gets after helping you be effective on the road and save materials and save time and maximize your productivity out on the road. The trucks that have the certified Cirrus Spread Smart controller are able to pass that data directly through to the MDSS Iteris. The older trucks that we have, they're not necessarily as digitized as the newer ones are. So how do we capture that information and pass it on? Well, on our tablet, we worked with Zonar to have an app on there for MDSS where they could manually fill in the information that would be captured electronically on a newer vehicle. So it's got drop-down menus on it where they can select, this is the type of material I'm carrying, this is my gallons or pounds per mile that I'm putting out there on the roadway, and here's the conditions I'm seeing on the road. It's iced over, or it's wet, or it's deep snow, it's wet snow. They can describe that through the system back to Iteris, so they can still capture the information and put that in the archive for future analysis and developing recommendations for future storms. Hopefully you guys can see that. This is a diagram of kind of how our truck talks to that system. So on the truck itself, you've got the AVL system, in this case Zonar, and the telematics system is the conduit again for the information that's coming out of the certified Cirrus controller. So that snowplow data comes out of the truck, and if it is Spread Smart equipped, it goes through the Zonar, it's channeled through Zonar, and then Iteris pulls that data in an API, through an API, and then it can show up on our cotrip.org or in our traffic operations center, and that way supervisors can see that information as well. So the public gets to see where the plow's at, the supervisor gets more detailed information of kind of what Steve was showing there of, you get a little box that shows where the truck is, how fast it's traveling, what materials it's spreading, at what rate. And we're not quite there where Steve was with the diagram that shows how effective the plow was on the road with that Vizsla graph, which I really like that, by the way. That's pretty cool stuff. Okay, if the vehicle is not equipped with a spread smart, then it's the manual input through the Z form, and that data is passed into Zonar and it's able to be pulled into Iteris through that path. So either way, we're getting that data right into Iteris rather. There's some other related projects that we're working on to enhance the capabilities of our snow plows and some of our other vehicles out on the roadways. Last year I talked about we were trying out some onboard Wi-Fi. One of the reasons we did that, as Steve noted, there's a large portion of our state where cellular is just not reliable. It's very sketchy at best. And so how do you communicate this information in that type of environment? We started testing out a system called CradlePoint, which is a vehicle-borne, basically a Wi-Fi or a router. It has a very robust antenna that goes on top of the vehicle. It's a big hockey puck-looking antenna that amplifies any existing cell signal so that you can have an opportunity to amplify that signal going out of the truck and still transmit that data back to where it needs to go. Or if you can't transmit because there is no cell signal, period, it has like a terabyte of onboard storage where it'll hold that data until you do achieve a signal, and then it will blast it out to wherever it needs to go. One of the things that the employees in the field are very interested and excited about is I can actually go out on the roadway and use my laptop or my tablet or whatever device I might have to get on there and do my work in the field. The situation they were in previously was they would have to go back to the patrol shed to have access to a laptop that's actually plugged in. Well, guess what? So is everybody else. So I got to stand in line, and it's 5 o'clock. I want to go home, and I got to stand there and wait my turn to complete my work order, my timesheet, or whatever it is. Now they have the capability to do that stuff in the vehicle on the job site. Additionally, the CradlePoint system has been integrated with the camera in some of our vehicles. So we get after some of those things that Bob was talking about, having the live feed. If one of our guys is responding to an accident or some type of an emergency, we can get pictures that the leadership back in Denver or wherever can look at those pictures and have a good feel for the situation. Or we can turn on a video feed if we want to use video and get real live video feed of a crash or accident scene or a natural disaster on the roadway. So it enhances that situational awareness that people who are making decisions about resources, it gives them another tool they can use to make those decisions. We've recently, over the past winter, and some of the guys that have been involved in that, Rob Brogdon and Matt McVeigh over here, their section was kind of taking the lead on the integration of friction sensors in some of our supervisory vehicles out in the field. And those are also tied in through this onboard Wi-Fi system to get the data back. And those are being integrated into Iteris as well. The information that's coming off of that Tacona friction sensor is an added layer of information that they can use to analyze performance in the storm and determine what treatment is enough or too much. Matt, correct me if I'm wrong, but last year I recall a couple of comments that came back from Tom Aguilar. They were watching the roadway with this friction sensor as the supervisor's driving it, and it was a decision point. There's a storm coming in. Do we want to treat this road or not? And because of the conditions that were indicated by that friction sensor, they determined that, well, it looks like we're not going to lose this road, so let's not put any material down. At that first time it was kind of this is a new system. Do we really trust it? Fingers crossed. Well, it turned out that the data that came from the system was correct, and they didn't need to treat that roadway. So that saved some materials. Did I miss anything, Matt?
Yeah, I think that's pretty accurate. I think it can change probably other states. from mile to mile, storm to storm, hour to hour, it can change instantly. Even less than a mile, it could change. So it's a good tool, great tool for making those decisions or assisting with those decisions. And kind of get in the weeds a little bit. You guys touched on it. It's helped in the other way too, as far as maybe something flash froze and there's some finger pointing, and it's a good justification to show, like, you know, there was trucks there. It works both ways. I know some of the drivers maybe don't like it, but they're starting to see the merit of it working the other way too. So I think it's a great tool.
And how are the guys in the field liking the onboard Wi-Fi, you know, for other stuff?
I think it's mixed, but I think it's they're pretty. That area is pretty good at embracing the new technology, trying it.
That's
so,
why I always give you guys new stuff. 'Cause
no,
you
we
guys aren't
appreciate
afraid
it.
to play with
We'll
it.
try it.
That's kind of where we're at today versus where we're at the last couple times I've talked to this group about our AVL system, specifically in our snow plows. In our light duty fleet, we've got 100% implementation with Verizon Network Fleet. Nothing really new or special about that. It is what it is. It does what it does. And the reason we selected that for our light duty vehicles is because it didn't oversolve the problem in the form of paying more than we probably wanted to pay for just basic telematics data. So that has worked for us. It's tied in with our fuel controls program, so we can verify fuel transactions. That's kind of where we're at today. I don't want to give you the idea that we haven't had challenges, issues, and problems, but we've been able to work through those. What's next? Starting to do some brainstorming about what's the potential to use this onboard Wi-Fi technology in our AVL systems, and to take that next step and do something else that's beneficial to the organization. Would it be possible, for example, to use that technology between the Bluetooth capabilities and Wi-Fi capabilities with that Cradle Point allows us? Can we maybe eliminate some electrical cable connections and go Bluetooth on some hydraulic controls? You know, eliminating, because we all know that cables and wires are one of the weak points on a snowplow truck when it comes to salt intrusion and corrosion. Is there potential that we could eliminate some cables? You know, maybe not, we don't know yet, but that's something we're thinking, maybe that's something we should look at. We've already looked at temperature sensors going forward. Instead of buying a hardwired temperature sensor for the truck, we're looking at putting in a Bluetooth capable temperature sensor. We've been talking to our truck builders about that. So that eliminates, you know, another wire in the system. Makes it easier for the guys if they ever have to change a component out, it's not wired in. What other emerging technologies are coming out there that might be able to be integrated in through this Cradle Point system? The nice thing about it is it's expandable. So you can, you know, there's I forget how many different satellite devices you can pipe in through the Cradle Point at one time, but I think it's in the couple of dozen range. You know, we're just looking at what else can this get for us? How can it make our system better than it is today? Any questions?
Just curious, I think all three of you guys said on the light duty side you're using Network Fleet, and a couple questions. The first one being, have you ran into any technical issues or issues specifically with Network Fleet in the last year or so with their hardware functioning with new vehicles? And then the other question I'd have is, maybe not from the fleet or from the fleet maintenance standpoint, but from your end user standpoint, what large outcomes or outputs, you know, what value do your end user groups see from on the light duty side for the Verizon, for the telematics?
To the first part, one of the limitations right now of Verizon Network Fleet that we've seen is in the electric vehicles coming out. That's not a viable telematics solution for an electric vehicle. So like California, you know, we only have about a dozen right now true electric vehicles. The others are hybrids. And we have the Chevy Bolts. So right now we're putting the Geotab into those Chevy Bolts because our state fleet management, who we lease our light duty vehicles through, they're already in contract with Geotab for those assets. So to get after the second question of, what benefit do the employees see, probably the biggest one, and guys chime in if there's any other that our average frontline employee sees, is in our fuel control system prior to the telematics, we had to have the employees keep their fuel receipts and maintain a fuel envelope and documentation of every single time they bought fuel, and it had to be turned into the fuel coordinator. So the fuel coordinator is getting this influx of fuel control envelopes and receipts every month that they had to manually process and verify every fuel transaction to detect any potential theft out there, inappropriate use of the credit card. And all that now, because we got telematics in the fleet and we're able to correlate that to a driver, a credit card, and a fuel pump, and put all those things together in the same time and place of a transaction, it verifies the legitimacy of that transaction, so we didn't have to retain fuel receipts anymore. So that is probably the hugest benefit that any CDOT employee would cite to you if you ask that question. And then, of course, there's the reduction in idle time. We were able to achieve that because of telematics as well.
I think for us, from a hardware function, I only know of one device that actually showed up this week where we were starting to see a failure on the device. So I don't know that that's been an issue. We're a little concerned about the fact that some of our devices may be 2G or 3G, and we know we're evolving to almost 5G. So we actually did have a conversation with Verizon, I think, last week, and they guaranteed us whatever the cutoff date through FCC or whatever, that they will retrofit all of those older devices at what point in time that they are about to fail. So from a hardware standpoint, I think we're okay. Jeffrey Kelly may have other things they want to jump in on that. From an operator standpoint, as we're, like I said, we're really just kind of scratching this, and it's been more about fleet management as opposed to operator benefit. But a couple things that have come into play, at least with Verizon Network Fleet, they have their 1-800 roadside assistance. So, if somebody gets a flat tire in the middle of nowhere, they can call that number, and Verizon will send somebody out to take care of it or tow them or whatever. We did have one situation where I think a guy got stuck in a van. So the network fleet was sending us sudden stops, sudden accelerations, just bang, bang, bang. We were trying to figure out what the hell this guy was doing, and we realized he was stuck, and he couldn't radio out to say he was stuck. So we were able to find him that way, so that was a benefit. But along Chris, I think some of the other things that we're wanting to do is through our fuel system, anytime somebody gets fuel, they have to they have a fuel card that identifies the vehicle. They have to input their employee ID or their security pin to get fuel, and they have to input meter readings. So we're hoping if we can go statewide 100%, that we can remove that whole aspect of entering fuel meter or meter readings, so that, because let's face it, anything manually input, the data sucks, or at least it's inconsistent. So that's one of the things we want to do, that we're trying to push to our districts. If you implement statewide, we can eliminate that from the operators having to do that, because we automatically get that information.
Since we've been with them, we've had a struggle with their employees. They can't seem to keep them. And so we never knew who we were calling. Every time we get a business card, it was not valid a month later. But we met with them a couple weeks ago, and they're kind of giving us the indication that they've got that sorted out. So we'll see where we're going to go from there. But it was a struggle. And then the other thing was training. And they kind of made a commitment to us a couple weeks ago that they would go to all of our districts and train each district how to use their system. Where before it was all just webinar based, videos that you could look at and sometimes understand, sometimes not. But those are some of the commitments they made to us.
We had the same issue with staff, and we finally got a dedicated person, but I'm not sure how long that person stayed. The other thing I would mention is, because someone mentioned it, that they were going to use the NASPO contract. One of the lessons learned from us is that you're not writing the contract, and you're not writing all of the terms and conditions and support that you want. So you're really getting promises, and hopefully, they want to keep your business or whatever. But that's one lesson learned. I mean, we did Network Fleet. It was good experience for us. We got it in, we got it quick. We didn't have to go through the RFP process, but that's kind of one of the downsides of that. And from a user perspective, maybe not necessarily a user perspective, But when we implemented network fleet, it was going to be, our intent was for asset management or for fleet management. But when you're sitting in the training and the division chief is sitting in the room and you see that a vehicle is doing 90 miles an hour, it's like, is that real? And you can't unsee that. And so you have to, yeah. You have to, that takes you kind of down a different road. You know, it was nice to say at the beginning, this is not for punitive, or we're not monitoring that, but you can't not do anything about that. And so that kind of took us down a detour where we developed these speeding reports and a whole process, administrative process in the department of notifying, you know, administrative deputies, so that something, and the whole progressive or not preventative, but coaching part of it. And then also, probably like many of you, we have take-home vehicles, and we have the permit process for that. Home storage permit is what we call them. We also created a whole suite of, or a sophisticated report to find out where those vehicles are garaging at night. So we have a garaging report, so we know where vehicles are spending the night. That also that was a detour that we took. So those are a couple of like unexpected kind of management tasks that we had to take care of when we implemented.
So to answer a couple more, a couple of your questions, yeah, we did have issues with zero emission vehicles, electric vehicles, and getting them to report. That was a problem. The benefits, and I'm surprised you didn't talk about this, Lisa, was car tags. We have trip reporting that we had to do manually. Every time you checked out a vehicle, you had to sign out who you were, where you were going, you know, how long your trip was, whatever, the mileage on the vehicle. When we went to GPS, all that's automated. Everybody got a fob. You fobbed into the vehicle, you identified who you were, and the GPS takes care of all the other reporting. So that was a big benefit for the users. I know the other thing that I didn't even realize was available was we had things called GPS jamming devices, which they actually exist. Well, I guess we had some instances of those, so that kind of came up. Another thing, the vehicle theft recovery. We actually had some vehicles that were stolen, and they're pretty easy. I don't think we've ever lost any vehicles now. We've recovered them because we could find them with the GPS and actually know where they went. Yeah, and Lisa already talked about the overnight reports, so that's some of the benefits we've seen.
Yes.
We've had the ARC, the Force America one. It works fantastic. So in the past, we always had the wire ones, and we're a little skeptical on the wireless, but it's working great. Basically, when the truck sets idle, it falls asleep. So as soon as they open the door and it jostles, we mount ours on the mirror. Once it jostles, it wakes it back up, and off you go.
Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.